Hello and welcome to this topic, the volume of mohe fungi. Mohe fungi is first studied by ancient Chinese mathematician Liu Hui in his book, The Notes to the Ninth Chapter on the Mathematical Art, or we say 九章算术注, when he tried to find the volume of sphere. It's a solid region common to two identical right circular cylinders. The Chinese meaning of mohe fungi is two square umbrellas. If you can find a couple of the square net umbrellas, like this, the umbrellas used to protect cakes from flies. So, two square umbrellas will make a reasonable approximation. Although Liu Hui came up with this problem, he didn't find the volume of it. About 200 years later, ancient Chinese mathematician Zu Chongzhi and his son Zu Geng found a formula for the volume of a mohe fungi and the volume of a sphere using elementary math. Suppose that the cylinder have radius r. So the radius is r, and one cylinder goes through another one. So we will find the common section. Then we can find the solid region common to this cylinder. The common section is called mohe fungi. To simplify the problem, by applying the symmetry, we can cut mohe fungi into 8 identical pieces by slicing it in three perpendicular directions. Now, take one of our pieces of mohe fungi and imagine it fitting into a cube of side r as shown. Finding the volume of mohe fungi is so hard that Liu Hui didn't find it. So, Zu Chongzhi and Zu Geng used a different way. Rather than finding the volume of mohe fungi piece, we shall actually find the volume of the rest of the cube, such as this piece. So they are the rest of the cube. Or we say the difference solid between the cube and the mohe fungi pieces. Now, let's slice it horizontally. Imagine taking a horizontal slice across the cube, like this. And this slice is height h above the base. If we look down at this slice, we will see a square side r. Of this, a square in one corner is part of the mohe fungi. So that is the right one. And the remaining L shape is part of the different solid. Now I have a question. What is the side length of the piece of mohe fungi? Please take 1 minute to think about it. Alright, now let's think where that slice came from. If you look at this front view of the cube, you will see this is a right-angled triangle. So this one is a right triangle. So using Pythagorean theorem, you will find that the piece of mohe fungi square has side length is square root of r squared minus h squared. And the area for the piece of mohe fungi is r squared minus h squared. So the area of the L shape will be the area of the bigger square minus the area of the smaller one. And that is r squared minus h squared, and it's equal to h squared. Wow, the area of L shape is h squared. So beautiful, isn't it? Now my next question is, could you think of another solid which, when we take a slice at height h, give us a slice of area h squared? In other words, the bottom slice has zero area, and the area gradually increases to a top slice of area R squared. It's a little bit hard. Now, let's consider an upside-down pyramid with a square base, whose height and side are both R. Now, what's the area of intersection of this pyramid by a plane parallel to its base and at a distance h from its vertex? Let's think about it. Because the side lengths and the height of the pyramid are equal, and the height of the intersection is h, so we see the side of the intersection is equal to the height of h. We find the side length of the intersection, then it is h. So the area of the section is actually h squared. Terrific! That means the area of intersection of the pyramid is equal to the area of the L shape. We can also show it with these pictures. We can see that the area of the yellow part is equal to the area of the blue part. Always say the area of intersection of the pyramid is equal to the area of the L shape. What a wonderful mathematical transformation! Now we can use the area of intersection of pyramid to replace the area of the L shape. It is deduced from Cavaleri's principle that the volume bounded by Mohr fungi and a small cube is equal to the volume of the pyramid, which is R cubed over 3. Hence, the volume of the part of Mohr fungi inside the small cube is 2R cubed over 3. So, the volume of whole Mohr fungi is 2R cubed over 3 times 8, and it's equal to 16R cubed over 3. Today, we followed the way of Zhu Chongzhi and Zhu Geng and found the volume of the Mohr fungi. It's a very nice trip. Thank you. I'm looking forward to seeing you next time.